quiz coming up later this week over this section. The quiz will not cover 3.3, but we'll start 3.3 tomorrow. Huh? Wait a minute.
On Friday, we'll cover 3.3.
Yeah, what's next?
3.4. It won't cover 3.4.
Oh, it won't cover 3.4. It'll cover 3.3. But we won't cover anything from Wednesday and Thursday. But if you know Wednesday and Thursday, it'll help you. We are. We're going to finish this up today. Oh, wait a minute. Do we do that one?
No. We stopped at 29 yesterday, so 30.
Oh, yeah. We did 30 because everybody had taken it to the fourth, and that's when almost everybody got it wrong, but, you know, except for a few people. Yeah, whatever. Okay, moving on. When you go to the back of the book and check your answers, you have to understand that in calculus there's different forms of the same answer. Because there's two ways quickly to do this problem, or there's two different ways I see that you can do this problem, or there's one answer written two different ways. I don't know. Chase?
Yeah.
How would you want to do it? You got two choices. You can go shortcut, or you can go simplify. Thank you. What? Simplify? I would too. This would become t of z equals 5z plus 1 minus 2z negative 2. This long division bar means you're dividing z cubed into each term. When you divide with the same base, you subtract the exponents. Therefore, you don't have to apply the quotient rule in your shortcut, but now you just apply the power rule because you simplified. Okay? A lot of people probably just saw the quotient bar and decided, quotient rule, I'm going to start in on that and start writing the derivative 20z cubed plus 3z squared. And then some people say, oh, wait a minute. You can simplify first and just do the power rule to take the derivative. End up with 5 plus 4z negative 3. They both will end up the same. Okay? But some people see the shortcut and some people don't. You know, you can continue on with the quotient rule if you want. Okay? Yeah, to the power of negative 3. Okay? If you allow with a positive exponent, you just put over z cubed equals t prime of z. Okay? The derivative of any constant, right, and the derivative of any linear term is the slope. Okay? So, yeah, you could have done the quotient rule, and you could have done the simplifying. There's always that choice when you take derivatives, always that choice when you take antiderivatives as well. You know, simplify it. Sometimes you have to simplify it, sometimes you have a choice. I say we move on. Nice. Do you know, well, I'll let you write down first. All right, Graham, what do you get for the derivative?
12x squared.
How to find some way to bring her back to class. Go ahead.
42x.
Good. Thank you. All right, Hammer, what do you do next? He's waiting for the voice of wisdom. No voice of wisdom. Read the instructions. What do the instructions say? Very good. So, remember, in your previous section, you saw several ways of writing the derivative. So you have to understand all the different ways to write it. Okay? So, this is just one way it says write the derivative. It's the instantaneous slope. And how do you solve that? You can do quadratic formula, quadratic program. I'll go with quadratic program, see if it still works. I got like 8 of them now I've typed. Second quit, clear, program, quadratic.
Why do you have like so many?
Because I retype them every year with the Trig kids.
Why do you still
Thank you. Okay. Delete, enter. 12, 42, negative 24. Okay. You did? All right. On this one, do both points work? 1/2 and negative 4. They do. It's not that difficult to see why. Do you remember how many vertices there are in a cubic function? Nope. There are 3 x-intercepts on a cubic function, or 3 zeros, I should say. Vertices is the number less, 1 less than a degree, so there's going to be 2 turning points on a cubic function. So it makes sense that there are going to be 2 places where the tangent line will equal 0. Okay? For a cubic. Now, what function has more than 2 vertices in a short amount of time? The trig functions. They have a lot of vertices. When you start solving those equations, you're going to have a lot of answers. Okay? Remember, where the derivative equals 0 is where the slope of the tangent line, or where the graph has a maximum or minimum, except in the following cases. This one is not a maximum or minimum, but the derivative still equals 0. This one is a sharp point. That's a cusp, correct? That is undefined. There's other places where it looks like that. But anyway, that's the right answer. Negative 1/2 or 1/2 and negative 4. All right? It doesn't say find any y value, so we're good shape. Nice. Change the directions. At 47 through 50, I just want you to find the derivative using the appropriate rule. If you'll use a limit definition, by all means, go ahead. Does anybody want to do the limit definition, check their algebra? No? Shortcut? Shortcut, okay. Simplify or shortcut rule? Okay, so you're going to do the quotient? Quotient rule? Well, it's your birthday. What do you want to do? Quotient rule it is. Birthday boy has spoken. Y prime. 2 times x to the 1/3. Oh, sorry, x to the 3/2. X to the 3/2. Minus 2x plus 3 times x to the 1/2, the 3/2 out in front. That's hard to see. Let me change it. All right. 3/2 x to the 1/2.
This is a rule you learned yesterday.
Quotient rule, you bet. F prime of g minus f g prime r g squared. 2x plus 3 over x to the 3/2. Okay, that's the rule we used. Quotient rule. The derivative of the top times the bottom minus the top times the derivative of the bottom all over the denominator squared.
So, like in this case where you have the square root and the square root, is it okay to do that? Simplify the bottom? Just makes it easier.
Yeah, you mean, we didn't really multiply it out, you just combine exponents. Yeah. All right, anything to factor out, Miss Griswold? Anything to factor out, or do you want to distribute? Interesting. Some would have factored, but that's okay. 2x to the 3/2 minus 3x to the 3/2 minus 9/2 x to the 1/2 all over x cubed. Vern. It was. What do you got for on this step? Well, I think you combine like terms first and then factor. Now what are you going to factor? All right, what are you going to factor out, Vern? What are you going to factor out? X to the 1, okay. If you want to take a negative along with it, you could. You want to? Congrats, birthday boy. Nice. Who's a grump back there? All right, so this is going to become X to what power? Kaylee. Is there more than one?
No,
Oh.
but I'm used to there being more than one.
Nice. What exponent is going to be left with this x after I factor out an x to the 1/2? Huh? What's 3/2 minus 1/2? Right. Okay. And then plus the 9/2 all over x cubed. Yeah, this is really getting. It needs to be. It needs to just finish. Okay. It needs to be done. I'm tired of messing with this. I'll get to a word problem. Negative x minus 9/2 all over x to the 3.5. Oh no. It'd be 2.5.
What did you do?
You can take that off.
Oh.
No, it's not. Yeah, because you got to sledge this out now since you did all that. You can't have a fraction within a fraction.
Net x to the 2.5.
Yeah. So we y prime equals negative 2x minus 9 over 2x to the 5/2. Hey, I didn't choose this route. I would have simplified first and done it in 2 steps. I asked your opinion.
You didn't tell us that we could take 2 steps. Can you show us the other way to do it too?
Sure.
Wow,
No.
you wrote this time. It takes 2 steps. What is that? Yeah, it's 2 steps.
Why don't we do it this way?
1.5.
Do the 1.
You're supposed to do an exponent and a number.
No. There's 2 different steps in one. This should just be x to the 5/2 down here. So I'm multiplying this by, I'm doubling the numerator, doubling the denominator to get rid of that 2. Okay? Numerator. So I get rid of the 9/2.
Okay, easy way.
The other way I thought you might do this problem was just to say, look, a single term right here, so this would be 2x to negative 1/2, 1 minus 3/2, plus 3x to negative 3/2. Multiply negative x to negative 3/2, minus 9/2 x to negative 5/2.
You multiply those together.
I'm subtracting them right there. I just dropped the exponents. That was just if you simplified it first. This is the derivative y prime right here in this step. I mean, you see some of the same numbers. You see the 5/2 and the 9/2, so you know you're pretty close. Okay? But you could have simplified it first, and then worked it out and got the final answer. We need a word problem. We need something like to
Well, we can still put it to.
bump up the volume, get you ready for the word problems on Friday.
You're really giving your score problem.
Yes, I won't be here,
Tuesday.
so I won't feel any daggers or
Seriously
anything.
putting more problems on the test?
Just a couple.
A couple, like how many? Isn't a couple 2?
2, yeah. 2. We'll go with that. Ready to go on?
General idea, yeah.
Ready?
Let's go to the second step.
I did the power rule. I dropped the exponent, subtracted. Okay? Fantastic. Oh, wrong way? Oh. Hey, wait a minute. Is 4 on here? 3 times 16 minus 2 times 2. Darn it. It is on there. Makes it easy. I'll let you do this one on your own. To practice, at least you practice once on your own before the quiz. Yep. Find the equation of the tangent line.
Yeah.
Y equals MAX plus B.
Oh, yeah.
Nope, you can use shortcut rule. Remember we said MA equals F prime of X. And the X is going to be 4. Did I get the answer?
Oh, no.
Nice! So it's on the graph. I think everybody in the room knows how to rewrite that, so I'm not going to waste that step. So far, so good, huh? No, they just find the equation. Just a friendly reminder, when you take a mixed number on the TI times a number, you need to use parentheses. Remember, mixed numbers. Now, yeah, you can do the decimal, but a lot of you won't know decimals for like 7/8, things like that. That's how you enter in a mixed number, 23.5, okay? I think we talked about that last year. You can, but I just said you won't know all the decimals all the time for all the fractions. Times 4. So 44 minus 94, negative 50. Clap, please. All right. Oh, what'd you get?
I got y equals 23.5 x minus 50.
Great. Y equals 23.5 x minus 50. So far, so good? Everybody's going to get it right on Friday.
Yep.
Great.
Provided I remember the rules.
Well, we went to the shortcuts. We said you don't have to use limit anymore,
Oh, yeah, we just.
and we said that's the definition of the derivative. Right.
Yeah, let's take a 3.3.
Oh, ho, ho.
Right now.
Now, let's do this.
Oh, this is important because this is terminology for the rest of the textbook.
Yeah, well, I wasn't free yesterday.
Here we go. The tangent line. Quiet, please, and listen. Tangent line perpendicular to this line. You're going to work with 2 lines. A tangent line touches the graph at one place. There's also, in this case, it's not the tangent line, in which the tangent line is perpendicular to the line 2y plus x. Perpendicular lines have, remember anything about their slopes? Riz, what do you remember about perpendicular lines? Exactly. Yep, perpendicular.
Don't think like this.
No, I can't put a visual on there. You have to tell me how to find them algebraically. Yep, when you multiply them, you get -1. Their slopes are opposite reciprocals. Now, I will tell you that the tangent line is the one you just found.
-1 over what?
M.
Oh.
the tangent line means your regular old garden variety tangent line. And perpendicular, yeah, the one we just found. It's not too difficult. You have to find this slope. So it's 2y equals negative x plus 7. Y equals negative 1/2 x plus 7/2. So the slope of this line is negative 1/2. They want to find all the points on the graph, so you have to have an x and a y for your answer, at which the tangent line is perpendicular to this line, perpendicular to this slope. Yeah, so you have to take the derivative, which is y prime, and set it equal to 2. So y prime has to equal 2. Then you solve for x, put it back in the equation, and find y. You can do a lot of calculations on the calculator, but you're going to have to do your algebraic simplification on paper. So the derivative would be 3 halves x to the 1/2 minus 1/2 x to negative 1/2. And just solve that for 2. I used the little shortcut power rule where I took the exponent, multiplied it, and subtracted 1. And I took the exponent, multiplied it, and subtracted 1. So, who should I call and see what they got for an answer?
Are we solving it for 2 or putting
It
x?
it has to equal 2. This equation has to equal 2. So,
We combined 57 with 50 for this one.
I know, isn't it great?
That's what I was confused.
No, you have to solve this.
So you minus 2 over the new.
Well, I'd multiply everything by 2 first. Minus x to negative 1/2. Then I look at the clock like about 4 of you just did in the last minute. And ask yourself, how do you solve this? You have years of algebra experience. Or you can do what I'm going to do and call on Abigail. How would you solve it? Ooh, that brings out middle terms, which... Oh, you mean factor? Okay. And that usually tells us that we can write the answer as... Now, how would you solve it?
Multiply over the x and 1/2.
Okay. First of all, you know x can't equal 0. And now you have 4x to the 1/2 equals 3x minus 1. Okay, I can square both sides. 16x equals 9x squared minus 6x plus 1.
And then, yeah. That's more complicated than it used to be.
No, this is like just like a middle of the road problem. Get ready for your quiz.
These are quadratic.
Yeah. What do you when you get to quadratic? Big number?
No.
9.
Oh, I guess that, yeah, it does have a 1 at the bottom. 22.
Is it negative 22?
No? Is it? Wait, what? Oh, I forgot the 6.
Now when you square both sides, don't forget that brings in extraneous roots. So how do you tell if it works? You what? You just go with both of them and hope it works?
Yes.
You do?
Yes.
Back of the book. I like that. Where are the people from 7th hour at? I thought for sure they would remember this.
You grab it. Grab it. Grab it.
Last year, something, yeah. Yeah,
Yeah, you
The middle one? No, yeah, the little one. I see the middle one all the time. I don't know his name, I just call him the middle one. I see that volleyball player too all the time.
Shelby?
Yeah, he said their name.
Shelby.
Yeah. Second? Yeah.
Oh, why did you do? Oh, because it was X. When did it cross one?
What? So, do you think both of them are actually solutions? Do you see two x-intercepts right there? Zoom in! Let's find out. Second, calculate 0 between 0 and 1 with a graph of 0.5. No. Nay, says the graph.
What did you just do? What did you plug in? What number is this?
Well, she was hoping that there was like a little sliver of hope right there, but there's not. Zoom 6. Second, calculate 0 from 0 to 5, 2.5. Hey, it is. Now we just have to find the y value.
Zero. Problem that never ends.
No, it's not. It is. We're almost done. You just have to put that number into the original, right? Look, it's not that difficult. Second and quit. Clear x caret 3 halves minus the square root of x. 2.165.
Me either.
Did you like store that in as a negative point?
It was stored when it was on the graph as x.
Oh, I didn't store it.
You don't have to.
It's already in there. And there's my answer.
Why is zero? I didn't get that.
Okay, ready?
5 minutes.
You think that's right?
I got 20.
I think
That's
it's
what I
all.
got too.
I got 5.
Nice.
Wait, time out. Why am I just working again? Did you graph it? My X is stored as 10, but my graph is still on there.
Did you use second calculate 0? There you have it.
That was ridiculous.
What was?
That question.
Oh, they get better. Just turn the page.
5 minutes.
5 minutes.
Taylor's. Oh, ho, ho, ho.
Wait, go back.
Yeah? Wait a minute. Who's the keeper of the time?
5 minutes.
Oh, thank you.
Actually 4.
Thank you. All right. Just a minute. Let me ask you 2 questions. I'll ask one of Alex, one of Sam, and if they get them wrong, Tamer will answer. How do you find velocity? Sam.
No, it's Alex. Remember?
No, he's gonna ask one of Alex.
Alex? How do you find the time which velocity is 30 centimeters per second? Set the derivative equal to 30 and solve. We did that. Matthew, how do you find the velocity at 2? Yep, you put 2 in for t of the derivative.
Yeah.
Very good. Nicely done. Okay? Ready? I think that's it.
Oh wait, you don't actually have to do it?
Not those.
No, I mean the last one.
No, you
What is
get,
S of, why don't we solve?
you gotta figure it out.
I think you can take the derivative and put it in 2.
Yeah.
Yeah.
And I think you can take the derivative and say equal to 30.
And then solve.
Right. It's in your book. All right. So yeah, you can omit 63 to 72.
I'll do another one.
Homer.
That problem again, please.
Sure.
Thank you.
You're welcome.
What do we have to go to? 61?
About 71.
You said omit 31 to 71.
It goes quick.
Omit what?
Oh my goodness. So we would go.
Yeah, omit.
So it'd be to 61.
Yeah, it'd be like 61.